In this video, I will demonstrate 3 ways to create hypsometry from open data provided by the Czech Office of Surveying, Mapping and Cadastre, or ČOZK, on its geoportal. You can find the link in the description. The basis for hypsometry is a raster, often referred to as digital elevation model, which contains values of elevations, and all you need to do is adjust its symbology into defined value intervals. In the first example, we will directly download this raster from the ČOZK and set its symbology. In the second example, we will use LAS data, which are Lidar points. In the last part, we will see what to do if you have contour lines for your area of interest, and you cannot or do not want to use the digital elevation model data from the ČOZK. On the ČOZK geoportal in the product list, locate Zabaget Altimetry DMR 5th generation and add it to your layers. Zoom in on the area you need and choose the Export Data option in the drop-down menu. In the pop-up window, click on Advanced Options. This allows you to draw a custom range for the exported data. Draw a polygon on the map and finish with a double-click. In the Format field, choose the geodatabase format, but make sure you select raster dataset. Finally, fill in your email in the upper part and click Export Data, and you will receive a download link shortly. By clicking on the link in your email, the download will start automatically. Open the downloaded zip file and extract the DMR5G database folder to your project folder. In ArcGIS, open the catalog pane. Under Folders, you have your project default folder. Refresh it by right-clicking it, and the new DMR5G geodatabase will appear. You can explore it by clicking the arrow, and you will see the Band 1 raster, our digital elevation model. Drag it into the map and you can start adjusting symbology. In the symbology pane, set the classification method to classify instead of stretch. This allows you to predefine the value interval. Then choose Defined Interval method and set the interval values for the elevation. For the Palava region, I will set it to 20 meters. Adjust the number of decimal places you want to have in the legend, choose a color scheme, and you're done. Now you can play with transparency and with base maps, and you're all set. In the second part of the video, we'll explore the use of Lidar data provided by ČOZK. On geoportal, select Zabaget Altimetry DMR 5th generation from the product list and add it to your layers. Zoom in on the area you need and choose the Export Data option. Similar to the previous example, click on Advanced Options in the pop-up window, which allows you to draw a polygon to define the export data range. This time, select LAS data as the format. Fill in your email, click Export, and you will receive a download link shortly. By clicking on the link in the email, the compressed file will download automatically. When you open the downloaded zip in the File Explorer, you'll notice it contains only one file. Extract it into your ArcGIS project folder. In ArcGIS, in the catalog pane, expand the folders and the default project folder. If the new data is not visible, try refreshing the folder through the right-click menu. Drag the DMR5G LAS file into the map. On the area I'm working on, you'll see that the Lidar data is more detailed in some areas, but entirely missing over water bodies. In these areas, the data is artificially interpolated through geoprocessing. Open the geoprocessing pane. If you can't find it, it's under Analysis and Tools. Now search for the LAS Dataset to Raster tool. This tool will create a raster output based on the Lidar data. In the input field, select or drag there the LAS layer and choose the location and name for the output. If you only change the name, the raster will be saved to the project's home geodatabase. If you want a raster format usable in other programs, choose a folder and include the appropriate extension with the name, for example, TIFF. Adjust the raster resolution in the tool settings according to your needs. The value is set in project units. In the Czech Republic, it's usually set to meters. I'm going to use a cell size of 2 meters for this example. It corresponds with the previous example using the downloaded raster from ČOZK. In the Environments tab, set the coordinate system of the output raster so that you are able to use it in other projects. For the Czech Republic, SJTSK is commonly used with the code 5514. Finally, just click Run at the bottom. After the calculation is complete, the raster will be automatically added to the map. The only remaining step is adjusting its symbology the same way as in the first example. In the symbology pane, set the classification method to classify and choose Defined Interval method. I will once again set the values to 20 meters. Then adjust the color scheme and decimal places in the legend as needed. For demonstration, I will switch between data from the original raster and LAS file again. You can see that the only difference is in the area, as I downloaded slightly different polygons from the GeoPortal. Otherwise, they are the same. In the final part, I will demonstrate how to create a raster base for hypsometry from contour lines. This can be useful if you are working in an area without Lidar data, or if you have more recent contours for your area. For this example, we'll use contours, which can also be downloaded from the ČOZK GeoPortal. The procedure is the same as in previous sections, so here's just a brief overview. Choose the Baguette Altimetry contour from the product list and select the Export Data option. Define the data range in Advanced Options, and the only difference is you select shapefile as the format. Fill in your email, extract all files from the downloaded compressed folder into a folder linked to your ArcGIS project. Again, your files should appear in the catalog pane. If not, refresh the folder. Drag the supplementary basic and emphasized contours into your map. For better looks, you can adjust their symbology, but it's not necessary for the following steps. In Geoprocessing pane, find the Topo to Raster tool, which can calculate a surface raster from various vector data. In the Input Feature Layer field, drag all contour layers. The tool should automatically recognize the field containing elevations and the line as a type representing the contour. Choose the location and name for the output. This time I will save it as a geodatabase raster. Set the cell size, the raster resolution, just as we did in the previous example with the value given in meters. Once again, I will use the same resolution of 2 meters to get comparable results. Finally, in the Environments tab, set the coordinate system of the output raster to SJTSK with the code 5514 and run the tool. For the area of this size, the calculation time is multiplied, so if your area is as big as mine, be prepared to wait for several minutes. Once the calculation is complete, the raster will be added to the map, this time with the symbology of basic hypsometry. If this meets your requirements, you're done, otherwise adjust the symbology. Change the method to defined interval in the symbology pane and adjust the interval according to your needs. Once again, I will use 20 meters. Select your preferred color scheme, adjust the decimal settings, and you're done. This output shows the most significant difference in the hypsometry due to the water reservoirs that are included in this area. While the first two rasters contain values for extensive water areas interpolated as one value, the missing data for contours resulted in values smoothly connected to the surroundings, which creates a depression in the water body. This can be resolved if you have the edges of water bodies for the Topo to Raster tool, and you can set them as lake line types. This video was primarily created to support students, so I appreciate any feedback and suggestions for future topics. If the tutorial helped you, give it a thumbs up and share it with your classmates who might also find it useful.